So, point to point communication, let me cover it. Well, I want to finish in 10 minutes, 5 minutes extra is okay. Okay, so send and receive, these are the name of the functions. So, I will illustrate using only two processors. Imagine only two processors. So, process 0, this is the data in your program, and this data has to be, well, this part of the data, okay, the data is big, but this data I want to send to P1. So, I send this data to buffer, typically a temporary location, buffer is like temporary location, and then send it that data to switch, like Ethernet switch, InfiniBand switch I discussed, no, and the switch will transport it to another buffer for the P1, now is crossing the side. So, is getting into the other processor area. So, receive buffer, and that buffer will send it to the program memory area. In fact, this data will be copied on that desired location. Is that clear? Now, this is what is done in send receive, which we did not need to do it for OpenMP or multi-threading. Sometimes the buffer is copied into a system buffer, then transferred, depends on the implementation. So, there may be this buffer is kind of common, well, free of the buffer, so that I can send more data, there may be the requirement, no. So, there is one copy here, then the system buffer, depends on the need, okay. You do not need to worry about this part, this part is done by the system. In fact, it is opaque, we can't even, I mean, I can't figure out what is happening. So, it is possible that send buffer will send to the interconnect, or there is another copy, then that goes to the interconnect. Now, how many copies are made here? There is a send buffer, possibly system buffer, then system buffer again, then receive buffer, then copy. So, they are in fact 1, 2, 3, 4 for the one operation, I mean the one method. There could be 6 copies in the other method, expensive, okay. Memory copying of huge data is expensive, and also there is a time required when you go across interconnect. So, communication tends to be quite expensive, okay. So, we need to send data only when required, we do not send data arbitrarily. So, let us look at the syntax. So, something called blocking send receive. So, there is something called blocking and non blocking. So, let me explain what blocking is. MPI send receive do not return, that means once I start the function, that will keep running until the respective buffer is ready for reuse. So, remember I had the buffer, this buffer, if the buffer is not emptied, then this guy send will just wait, it is sending, no. So, well, buffer is not empty, I do not know data will be sent or not, I just want to make sure the data is sent. It is safe programming, but in terms of time it is expensive, right, you have to wait for a long time. So, send is basically waiting until buffer is empty for you, reuse both sides, receive also until the receive buffer is emptied and ready to copy in the main memory, well, copying already, then you can start, but you do not need to wait for the data to be copied in receive, that is a misunderstanding. As soon as the send buffer is emptied, the send can start working. So, once the send, the data is already crossed the interconnect, so is good to go, or it copied to system buffer, then also good to go, but the send buffer must be free. For send, content of send buffer has to be either reach the receive buffer or it has been stored somewhere else. This could be system buffer. Okay. For receive also same stuff, receive buffer is copied into data block. Okay, so syntax is the following. So, I have two processors. So, this got I write the program like this. Okay. So, pay attention, this is critical. If rank equal to 0, then data, I create a data 0 to 1 and the name is a string 0 to 1. Com dot send, okay, is a function of that object com dot send the communicator. So, data name, data variable and where to send. So, right now destination is 1. Okay. So, 0 is master node, is sending to worker 1 and I just print for testing, sending from 0 to 1, data 0 to 1. Okay. It could be any variable here. Okay. It could be number, string, whatever, array also. So, this will send, but rank 1 has to receive it also, right. I mean, otherwise the job is not done. So, this part is the sending part. Now, the receiving part. So, receiver has to know where I am getting the data from and where should I store it. So, rank equal to 1, then it is stored in data, this data, and the source is given, where it is coming from. So, destination and source, these are keywords. Okay. So, destination is dest and source is source, and this function receive will receive the data and will copy it into variable called data. Okay. And I am printing it here. So, when I run it by two processors, this function, I say, well, this first line is printed, sending from 0 to 1, and receiving, this guy will print receiving from 0 to 1. Okay. So, this simple syntax, but whether is it possible that receiving can happen before sending? No, never, receive cannot happen before sending. Okay. So, there is another syntax. I mean, there are several ways to do it. If you look at the documentation, there are probably 4 or 5 ways to do send receive. So, this is with buffer explicitly specified. Okay, this buffer. So, this is a variable name random, which both these guys know, everybody knows random, slave as well as master, that there is a variable called random. So, I am doing same send receive, but with buffer, which is common to both. By the way, not sorry, I should not say common. Each processor had its own buffer, but that is already declared. Okay. For example, random in master and worker will be different numbers, could be different numbers, they are different variable locations. Okay. So, I initiate to 0. So, right now everybody is 0. Now, if rank equal to 1, then rank 1 is sending now. Okay. This is slightly different example. So, I create a random number, then I just print whatever I created, then send. So, send random number and destination. Okay. I send it. Now, this is sending to 0. So, 0 has to be ready and receive it, right. So, if rank equal to 0, then I am printing the value before receiving, then receive. Where should I receive it? So, in earlier slide you might have noticed that the variable was here equal to, but in this syntax it is not equal to. By the way, the difference is that this first letter is block, capital letter. In earlier slide it was small letter, that is the only difference. So, Python is compact and this random and source equal to 1. Where is it coming from? Source equal to 1. So, now random 1 will be different number and it will be same as what has been sent. Okay. Let us execute them. So, process 1 creates this line, creates this number, big number, random number 0.1896. Now, look at the number, process 0, this line is being printed, this one, initial number is 0, but then after it, so this number was 0 when process 1 was 0.189, same number, okay, this random 0. So, these are independent variables in two processes, that is why memory is separate for the every process, and then I print it after I receive it, and these two numbers are the same. Okay, this via buffer. So, how do I test it? MPI codes, you can do it in a laptop, but that is not the final test. Laptop is not using interconnect. Okay. So, the real test is until you use interconnect, you are not sure your program is working, and you can use as many processors you want in a laptop. You can use 16 if you like, it is okay. It will not be scaling with 16, but you can run it, but you need to use interconnect. Okay. You no guarantee your code will work with in the cluster. So, we will try to provide this at the end. You can test your code in your Colab or laptop. So, let us cover this one called deadlock, and I will end after this. Okay. So, let us finish this part. So, two processors both are sending. So, in the earlier example, one sent and other received. Now, imagine that process 0 is sending and process 1 is also sending different data. Now, what will happen? In a blocking send receive. So, this guy is sending, but process 1 is not ready to receive, he is also sending. So, will this buffer be emptied or not? Buffer will not be emptied. So, this guy is waiting for 1 to receive, and process 1 is waiting for process 0 to receive. This is called deadlock. Okay. This is not the way to write program. In fact, it hangs, nothing will move. So, the simple way to unblock this or remove the deadlock is first P0 is sending, then this guy should receive, and after receiving send. So, you change the order. Okay. After receiving you send, okay. And this guy is sent, now this guy is ready to receive. So, you just change the order and that works. So, rank 0 send first and rank 1 is, this is a block, sorry, this is a deadlock, this is deadlock. Okay. Both are sending. Okay. This simple example is there in, well, I will share the slides. So, both are sending simultaneously deadlock, and to remove the deadlock, as I said, send, then it should be receive it, received by P1, and then this guy is going to send P1 and this will receive. So, P0 is sending and P1 is receiving, and then P0 is receiving and P1 is sending, or P1 is sending and P0 is receiving. There is another way to end the deadlock is by this new function called send receive. Okay. So, what does send receive does? It sends the data. So, there are two variables now. This is to be sent. So, destination is 1, but I am getting some number or some variable, I receive it here. So, in one line we can send and receive, but MPI function will take care of removing the deadlock. So, it will take care of the, okay, I am sending it. So, I should, the other guy should receive first. So, this is managed by MPI, and for rank 1 it is again using the same function, but this is to be sent from 1 to 0 and received is here. Okay. So, I think I will stop here.